According to the National Electrical Code, NEC 2005, it is not permitted to run Romex, which is formerly known as Type NM cable, through Schedule 40 PVC conduit underground. The NEC provides specific guidelines regarding the appropriate use of different wiring methods, and in this case, the code prohibits the direct burial or underground installation of Type NM cable. Article 334.20 of the NEC 2005 addresses conduit bodies and fittings, stating that all conduit bodies and fittings shall be approved for the purpose. This means that any components used in an electrical installation must be specifically designed and approved for the intended application. This is to ensure that the materials can withstand the environmental conditions and provide adequate protection for the conductors. Article 352.10 of the NEC 2005 outlines the use is not permitted for Type NM cable. Specifically, subsection 6 states that Type NM cable shall not be used underground, direct buried, or embedded in concrete. This restriction is in place because Type NM cable is not designed to withstand the moisture, chemicals, and physical stresses associated with underground environments. Direct burial or embedding in concrete can lead to the deterioration of the cable insulation, which can result in electrical faults, short circuits, and potentially hazardous conditions. There is an exception to this rule. Where underground installations are necessary, Type NM cable is permitted to be installed in a raceway approved for direct burial. This exception recognizes that in certain situations, it may be necessary to run Type NM cable underground. However, to ensure safety and compliance with the code, the cable must be protected by a raceway that is specifically designed and approved for direct burial applications. A raceway is an enclosed channel designed to hold and protect wires and cables. Common types of raceways include conduits, tubing, and cable trays. When installing Type NM cable underground, the raceway provides a physical barrier that protects the cable from moisture, chemicals, and physical damage. It also helps to contain any potential electrical faults, reducing the risk of fire or electric shock. Schedule 40 PVC conduit is a type of plastic conduit commonly used in electrical installations. While it is suitable for many applications, it is not always approved for direct burial. The suitability of Schedule 40 PVC conduit for direct burial depends on several factors, including the specific type of PVC material, the installation depth, and the local soil conditions. It is important to consult the manufacturer's specifications and local codes to determine if Schedule 40 PVC conduit is approved for direct burial in a particular application. Therefore, to comply with the NEC, Romex, or Type NM cable cannot be run through Schedule 40 PVC conduit underground without first being protected by an approved raceway. The approved raceway must be suitable for direct burial and provide adequate protection for the cable. Failure to comply with these requirements can result in code violations, safety hazards, and potential liability. When planning an electrical installation that involves underground wiring, it is essential to carefully consider the applicable codes and regulations. The NEC provides detailed requirements for the selection, installation, and protection of different wiring methods. By following these requirements, you can ensure that your electrical installation is safe, reliable, and compliant with the law. In summary, while Schedule 40 PVC conduit can be used in some underground electrical installations, it is not sufficient to protect Type NM cable. To comply with the NEC, Type NM cable must be installed in a raceway specifically approved for direct burial. It's always best practice to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. This is especially important for underground wiring projects, where environmental conditions can significantly impact the performance and safety of the electrical system. Let's delve deeper into the specific aspects of NEC 2005 and its implications for using Romex, or Type NM cable, in underground applications. We will explore the rationale behind the code's restrictions and provide a comprehensive understanding of how to ensure compliance with the NEC when dealing with underground wiring. The primary reason for the NEC prohibition of direct burial of Type NM cable lies in the cable's construction and its vulnerability to environmental factors. Type NM cable typically consists of two or more insulated conductors enclosed in a non-metallic sheath. This sheath provides some protection against physical damage, but it is not designed to withstand prolonged exposure to moisture, chemicals, or the abrasive forces present in underground environments. When Type NM cable is buried directly in the ground, the non-metallic sheath can degrade over time due to moisture, soil acids, and other corrosive elements. This degradation can compromise the insulation of the conductors, leading to electrical faults, short circuits, and ground faults. These faults can create dangerous conditions such as electrical shock hazards and the risk of fire. Furthermore, direct burial of Type NM cable can make it difficult to locate and repair any faults that may occur. The cable is buried underground, making it inaccessible for inspection and maintenance. This can result in prolonged outages and increased repair costs. The NEC recognizes that in certain situations, it may be necessary or desirable to run Type NM cable underground. For example, a homeowner may want to install an outdoor lighting system or provide power to a detached garage. In these cases, the NEC allows the use of Type NM cable underground, provided that it is installed in a raceway approved for direct burial. A raceway is an enclosed channel designed to hold and protect wires and cables. It provides a physical barrier that protects the cable from moisture, chemicals, and physical damage. It also helps to contain any potential electrical faults, reducing the risk of fire or electric shock. Several types of raceways are approved for direct burial, including rigid metal conduit, intermediate metal conduit, and rigid PVC conduit. These raceways are specifically designed to withstand the harsh conditions of underground environments. They are made from durable materials that are resistant to corrosion, moisture, and physical damage. When selecting a raceway for direct burial, it is important to consider the specific requirements of the application. The raceway must be sized appropriately to accommodate the number and size of the conductors being installed. It must also be installed in accordance with the manufacturer's instructions and the applicable codes and regulations. In addition to providing physical protection, a raceway also provides a means of identifying and locating the cable underground. The raceway can be marked with warning tape or other identification devices to alert excavators to the presence of the electrical cable. This helps to prevent accidental damage to the cable during digging or other underground work. When installing Type NM cable in a raceway underground, it is important to ensure that the raceway is properly sealed to prevent moisture from entering. Moisture can damage the cable insulation and create electrical faults. The raceway should be sealed at all joints and connections using waterproof sealant or fittings. It is also important to provide adequate drainage for the raceway to prevent water from accumulating inside. In addition to the requirements for raceways, the NEC also specifies requirements for the depth of burial for underground electrical cables. The depth of burial depends on the type of cable, the voltage, and the location of the installation. Generally, cables must be buried deep enough to protect them from physical damage and to prevent them from being disturbed by digging or other underground work. The NEC also requires that underground electrical cables be protected from physical damage by placing them in a trench with a layer of sand or other suitable material. This helps to cushion the cable and prevent it from being damaged by rocks or other debris. In summary, the NEC prohibits the direct burial of Type NM cable because it is not designed to withstand the harsh conditions of underground environments. However, the NEC allows the use of Type NM cable underground, provided that it is installed in a raceway approved for direct burial. The raceway must provide adequate protection for the cable and must be installed in accordance with the manufacturer's instructions and the applicable codes and regulations. By following these requirements, you can ensure that your underground electrical installation is safe, reliable, and compliant with the law. Now, let's focus on the specifics of Schedule 40 PVC Conduit and its suitability for use as a raceway for Type NM cable underground. Schedule 40 PVC Conduit is a type of plastic conduit commonly used in electrical installations. It is made from polyvinyl chloride, a durable and versatile thermoplastic material. Schedule 40 PVC conduit is available in a variety of sizes and is typically used for both above-ground and underground applications. One of the main advantages of Schedule 40 PVC conduit is its resistance to corrosion. PVC is not affected by moisture, soil acids, or other corrosive elements. This makes it an ideal material for underground applications where corrosion is a major concern. Another advantage of Schedule 40 PVC conduit is its lightweight. PVC is much lighter than metal conduit, making it easier to handle and install. This can reduce labor costs and make the installation process more efficient. Schedule 40 PVC conduit is also relatively inexpensive compared to other types of conduit. This makes it a cost-effective option for many electrical installations. However, Schedule 40 PVC conduit also has some limitations. It is not as strong as metal conduit and can be damaged by impact or crushing forces. It is also not as resistant to high temperatures as metal conduit. Schedule 40 PVC conduit is typically rated for use in temperatures up to 75 degrees Celsius or 167 degrees Fahrenheit. The suitability of Schedule 40 PVC conduit for direct burial depends on several factors, including the specific type of PVC material, the installation depth, and the local soil conditions. Some types of Schedule 40 PVC conduits are specifically designed and approved for direct burial. These conduits are typically made from a more durable PVC material and are designed to withstand the crushing forces and other stresses associated with underground environments. Other types of Schedule 40 PVC conduit are not approved for direct burial. These conduits are typically made from a less durable PVC material and are not designed to withstand the harsh conditions of underground environments. When selecting Schedule 40 PVC conduit for an underground installation, it is important to consult the manufacturer's specifications and the applicable codes and regulations. The manufacturer's specifications will indicate whether the conduit is approved for direct burial and will provide information on the installation depth and other requirements. The applicable codes and regulations will also provide guidance on the use of Schedule 40 PVC conduit in underground installations. In some cases, the codes may require the use of a specific type of Schedule 40 PVC conduit or may impose additional restrictions on its use. Even if Schedule 40 PVC conduit is approved for direct burial, it is still important to take precautions to protect the conduit from damage. The conduit should be installed in a trench with a layer of sand or other suitable material. This will help to cushion the conduit and prevent it from being damaged by rocks or other debris. The conduit should also be installed at the proper depth to protect it from physical damage and to prevent it from being disturbed by digging or other underground work. In summary, Schedule 40 PVC conduit can be used for underground electrical installations, but not all types are approved for direct burial. When selecting Schedule 40 PVC conduit for an underground installation, it is important to consult the manufacturer's specifications and the applicable codes and regulations. It is also important to take precautions to protect the conduit from damage. So, to reiterate, the question was whether it is against NEC 2005 to run Romex through Schedule 40 PVC underground. The answer is yes. It is against NEC 2005 to run Romex through Schedule 40 PVC underground without the proper direct burial rated raceway. To fully comply, first consider that Article 334.20 addresses conduit bodies and fittings. Article 352.10, use is not permitted, further outlines that Type NM cable shall not be used underground, direct buried, or embedded in concrete. The exception is where underground installations are necessary. Type NM cable shall be permitted to be installed in a raceway approved for direct burial. Therefore, Romex or Type NM cable cannot be run through Schedule 40 PVC underground without first being protected by an approved raceway, for example, a conduit. The reason for this is that Romex cable is not rated for direct burial, so using a conduit that is rated for direct burial is required so that the cable is not damaged and will last its designed life expectancy. Failing to follow these guidelines could create an unsafe situation due to the potential of shock or fire due to damaged cable. To further add more clarification of how to properly select a raceway approved for direct burial, there are several options. Rigid metal conduit, or RMC, is a heavy-duty steel conduit that provides excellent protection for cables in harsh environments. It is commonly used in underground applications where there is a risk of physical damage or corrosion. Intermediate metal conduit, or INC, is a lighter weight steel conduit that offers similar protection to RMC but is easier to install. It is also commonly used in underground applications. Rigid PVC conduit is a non-metallic conduit that is resistant to corrosion and chemicals. It is a popular choice for underground applications where these factors are a concern. When selecting a raceway for direct burial, it is important to consider the following factors. The type of cable being installed. The raceway must be sized appropriately to accommodate the number and size of the conductors being installed. The environmental conditions. The raceway must be made from a material that is resistant to the specific environmental conditions at the installation site, such as moisture, chemicals, and temperature extremes. The potential for physical damage. The raceway must be strong enough to withstand any potential physical damage, such as impacts or crushing forces. The applicable codes and regulations. The raceway must comply with all applicable codes and regulations, such as the NEC. In addition to selecting the proper raceway, it is also important to install it correctly. The raceway should be buried at the proper depth to protect it from physical damage and to prevent it from being disturbed by digging or other underground work. The raceway should also be properly supported and secure to prevent it from shifting or settling. When installing a raceway for direct burial, it is important to follow the manufacturer's instructions and the applicable codes and regulations. This will ensure that the raceway is properly installed and will provide adequate protection for the cables. Also, keep in mind that when working with electricity, there are inherent risks involved. It is important to take precautions to protect yourself and others from electrical shock and other hazard. Always to energize the circuit before working on any electrical equipment. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable codes and regulations. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Working with electricity can be dangerous, and it is important to take precautions to protect yourself and others from harm. Sir, after clarifying the NEC stance on direct burial of Romex cable and the considerations for selecting and installing approved raceways, let's discuss some practical tips for ensuring a safer and compliant underground electrical installation. Firstly, always obtain the necessary permits. Before starting any electrical work, especially underground installations, obtain the necessary permits from your local building department. This will ensure that your work is inspected and meets all applicable codes and regulations. Secondly, plan your route carefully. Before digging, carefully plan the route for your underground wiring. Avoid areas where there is a risk of damage from digging or other underground work. Also, be aware of any existing underground utilities such as water pipes, gas lines, and sewer lines. Thirdly, call before you dig. Before digging, call your local one-call center to have underground utilities marked. This will help you avoid damaging any existing utilities and prevent potential hazards. Fourthly, use the proper tools and equipment. Use the proper tools and equipment for digging, installing conduit, and pulling wire. This will make the job easier and safer. Fifthly, install the conduit properly. Install the conduit at the proper depth and with the proper slope to prevent water from accumulating inside. Also, be sure to use the proper fittings and connectors to ensure a watertight seal. Sixthly, pull the wire carefully. When pulling wire through conduit, use a lubricant to reduce friction and prevent damage to the insulation. Also, be careful not to pull the wire too tightly, as this can damage the conductors. Seventhly, test the installation. After completing the installation, test the wiring to ensure that it is properly grounded and that there are no short circuits or ground faults. This will help to ensure that the installation is safe and reliable. Eighthly, document the installation. Keep a record of the installation, including the location of the wiring, the type of conduit used, and the depth of burial. This will be helpful for future maintenance and repairs. Ninthly, use ground fault circuit interrupters. Install ground fault circuit interrupters, or GFCIs, to protect against electrical shock. GFCIs are required in many locations such as bathrooms, kitchens, and outdoor areas. 10thly, hire a qualified electrician. If you are not comfortable working with electricity, hire a qualified electrician to do the work. A qualified electrician has the knowledge and experience to ensure that the installation is safe and compliant with all applicable codes and regulations. By following these practical tips, you can ensure a safe and compliant underground electrical installation. Remember, electrical work can be dangerous, and it is important to take precautions to protect yourself and others from harm. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before starting any electrical work. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. The NEC is adopted by many states and local jurisdictions, and it is the basis for most electrical codes in the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is an essential resource for electricians, contractors, and anyone else who works with electricity. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical work, such as wiring methods or equipment installation. Articles provide more detailed information on specific topics within a chapter. Sections provide specific requirements for particular applications. The NEC is a complex document, but it is important to understand its basic principles. The NEC is designed to protect people and property from electrical hazards. It sets minimum standards for electrical wiring and equipment to ensure that they are safe and reliable. The NEC is not a design manual. It does not tell you how to design an electrical system. However, it does provide the requirements that must be met to ensure that the system is safe. The NEC is not a substitute for professional judgment. It is important to use your knowledge and experience to make informed decisions about electrical installations. The NEC is constantly evolving. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date with the latest version of the NEC to ensure that your electrical work is compliant with the current standards. The NEC is available from the National Fire Protection Association, or NFPA. The NFPA also offers training courses and other resources to help you understand the NEC. The NEC is an essential resource for anyone who works with electricity. It provides the standards that must be met to ensure that electrical installations are safe and reliable. By understanding the NEC, you can protect yourself and others from electrical hazards.